Yes, sir. Started recording.
Where is that provision?
I think at the bottom itself, sir, in the 4 lines is there. No? There only.
Okay.
Where share is there itself it will be. There are good features in this WebEx, sir, actually. You can assign, earlier I have to control, sir. Now I can give you the control actually from this. You can proceed. The voice control, the voice is also much better in WebEx, I guess. Isn't it, sir? Yes, isn't it, sir? Yeah, clarity will be, the video
Yes,
clarity.
in many aspects, WebEx is better than Google Meet, sir.
Correct.
Oh, very good. But how about data consumption?
That will be little higher.
WebEx is slightly more, consume slightly more, sir.
Okay. And that time, last time, your seniors experienced that. You have 128. That's 120.
40 and 40 maybe. 40 from A section and 40 from B section.
One series is more than 2 series, I think. More A section people than
B section, sir.
Yeah. One not one is not there. 1 not 2, 3 not there. 4, 5, 7, 8, 9, 10, 10, 11 not there. 12, 13 not there. 15, 16, 17, 18, 20, 21 not there. So some
Gupta sir, now you are sharing, sir.
Sorry, sharing the screen now.
Anybody can do that. I can restrict, but I allowed that anyone can share.
Okay. Among the faculty, yeah?
Among the students also, if they want to share, immediately they can do.
Okay. If they have done some calculations, so they can share
Yeah,
it.
they can immediately share and show it.
Okay. Dasari Charan Mitra is a student.
Yes, sir. There is no TA with that.
They are TS, huh?
They are no TA with that.
No, Hanuman Naik, Kaushik, they don't have numbers. Maybe they joined through mobiles. That's why it is not displaying numbers. Okay. Those who joined with mobile, no? For them, number is not displayed.
For everyone, if we are joining through mobile, we can also put numbers.
Okay.
Sir, I have joined through laptop, sir.
Okay, some people know, like Pranay Kumar, Deepak Das, Akhil Reddy, Saurabh, Dasari Charan, Hanuman Naik, Kaushik, Laya, Sarthak, Vishnu. They are all with mobiles. Mobiles means you are on the travel or outside?
Sir?
Mobile, when you are joining with mobile means, what does it mean?
Sir, I have joined through laptop only, sir.
But people who are
Headphone signs means laptop, sir. Phone sign means phone, sir.
yeah. Let us say Saurabh phone symbol is there.
Yes, sir.
Yeah.
For participant phone also no problem, sir. Same, it will be like same.
But once they are in at a fixed place, no, better to join through laptop. Anyway, the choice lies with the students.
Sir, some of us like to take screenshots of notes you are sharing, so we join through phone.
No, we don't want to give that scope to you. We are sharing as much as possible information as we want to share with you. There is nothing like a
Sir, some people may face power cut off, something like that, so they might join sometimes through the phone.
Okay.
Many use mobile data, sir. So connecting mobile data again to laptop, it's difficult.
Okay. One 34.
134, sir.
Whenever you say no, we'll start slowly.
Yes, sir. It's up to you, sir.
We can start now, sir.
Shall we start?
Should I start, sir?
Yeah. So, shall I give some introduction?
It's up to you, sir.
You shared
you can-
that one, no, first page.
Yeah, first page.
So it's only some hint. You started recording the session, no?
Just a moment, sir. Yeah, recording is happening, sir.
It's simultaneously going on. Huh?
Yeah.
Okay. Good afternoon, everyone. Today we'll be seeing the experiment that is a fourth experiment in the first cycle of experiments. So the title of the experiment is heat balance test on a single cylinder diesel engine. So again, the significance of this diesel engine is that as it is convenient to conduct experiment on single cylinder engine, and again this particular engine is a Kirloskar make engine. So kindly share that.
Which one, sir?
First page you shared, no? Just now, some time back.
It is sharing, sir. It's not visible.
No, for
Sir,
me,
screen is blank for all of us.
blank it is.
Screen is black.
It's a blank.
Just I'll reshare it. Now is it visible, sir?
It's a totally plain white. It's starting to share like that. It is displaying.
Yeah, probably it's streaming here. It's not responding, sir. I'll just. Is it visible, sir?
Visible and just I'll join in a minute.
Okay, sir.
Yeah, Dr. Sampath.
Yes, sir.
Yeah, as I was telling you, know, this particular experiment is a heat balance test on Kirloskar engine. Make is a Kirloskar, it is single cylinder water cooled vertical cylinder diesel engine. As the name suggests that we are balancing. What we are balancing, we are trying to see how the energy distribution takes place in a typical diesel engine. So it is also called energy balance test. So whatever input we are giving in the form of a fuel, which carries some calorific value, no? So how that energy is being distributed. So as I told you, that engine is a classical example of corollary of second law of thermodynamics, and our engines, they work under the constraints of laws of thermodynamics. So unless there is a sink, unless you lose or unless you dissipate the heat in another form, so the useful power cannot be obtained. That was the statement given by the Kelvin Planck statement of second law of thermodynamics. So accordingly, our engines are functioning. So in a practical engine, how that engine energy distribution takes place. So for that, we are conducting the experiment. So the basic aim of this experiment is to conduct a heat balance test on Kirloskar engine at full load. In our experiment, we have conducted half the full load and at rated speed and draw up a heat balance test on kilowatt basis. So these are the specifications of engine, what I have shown earlier. We conducted an engine performance test on a Kirloskar engine, which was connected to a DC shunt dynamometer. So the specifications of that engine and the engine on which we are performing the heat balance test are one and the same. So the data of the fuel is as follows, and what we require in addition to the engine test setup are a fuel flow meter, stopwatch, tachometer, the thermometers. At a strategic locations, we require thermometers, and the bucket means measuring jar. Instead of a bucket, we have a measuring jar, and we have what is called a spring balance. Instead of a spring balance, no, I told you earlier we used to have some bucket where we collect the water from the engine outlet, jacket water outflow, and with the help of a spring balance, we used to weigh that water and know that how much water is flowing through the engine. Of course, the engine is incorporated with the exhaust gas calorimeter. So these are the basic instrumentation we require for the conduct of heat balance test. So as I told you, that heat is given in the form of a fuel, mass flow rate of fuel multiplied by calorific value of fuel, and this term, the product mass flow rate of fuel multiplied by calorific value of fuel, that we have taken as a denominator while calculating the thermal efficiency of an engine. Do you agree with me? Please say yes or no.
Yes, sir.
Yeah. So, hoping that you would have calculated the required calculations in a performance test on a single cylinder engine, what I explained last class. Okay. So that denominator is the heat input, and the heat input when we are given, and we also observed that you have got some efficiency like 28%. How much thermal efficiency at full load you got it? Can anybody give the values? Sarthak, Vishnu, Akshay, Alan, whoever maybe. You have calculated, no? Sudarshan Reddy, Geeta, Manoj, somebody should speak out. Adisheshu, Akshay, no response?
So what sir is asking is how much performance efficiency you have got in the last experiment that you carried out. So already submitted, right? So at 1500 RPM, what was the mechanical efficiency?
There is a column wise the thermal efficiency, mechanical efficiency, indicator thermal efficiency. Okay.
Brake thermal efficiency was around 19. Highest was 19, I think, sir.
Okay, 19 is a very Normally, in a good condition, the diesel engine, one obtains about 35 to 40%. Okay, so that means out of the energy supplied in the form of this input heat, which is multiplied with the mass flow rate of fuel, you may get some kg per hour or kg per second, so many kilowatts input energy. So only in a good running engine, about let us say 40% is available at the utility point. So remaining 60%, what is happening? So as I told you that there is remaining 60% is going in as a waste. It is not a waste, but you cannot obtain a efficiency more than 50% as a thermal efficiency. So there is a constraint put by our Carnot cycle, no? So based on that one, some energy is going in the form of exhaust gases. As you have experienced that if you keep your hand at the exit of an silencer vehicle, so you feel very hot and they are living at higher pressure. So there is some pressure energy and thermal energy going out. Similarly, engine components surrounding there are fins or there are jacket waters, no? You have to protect the components from getting overheated. Okay, so that means some part of energy is also going through the coolant water. So out of this 100%, 40% as a maximum available as a thermal efficiency or as a useful brake power output, and 30% typical engine will lose energy in the form of exhaust, and 30% is or 25% as a cooling losses. So 40 plus 30 plus 25, it is coming around 95. Remaining 5 we cannot account it whether it is because engine is when it is hot, no, it may also radiate some heat, but there is no measure how exactly you calculate it. So we are not trying to exactly account it for that one. So we try to put it in the unaccounted losses. So as a crude example, I give you. Suppose if you are coming to the hostels, let us say after from vacation or from your home, your papa may give you 10,000 rupees as a monthly expenditure. So with an expectation that you would pay about 6,000 towards your food expenses in the hostel, remaining 4,000 as an expenditure towards your books or something. What do? You will try to manage your food amount to 6,000. You cannot do it, but 6,000 you are paying in the hostel. Out of this 4,000, you are trying to go to movies, no, and you will give to your friend as some loan, or you would have borrowed some loan from your friends and you will pay back it. And sometimes no over expenditure you will do. So likewise, you will try to manage. If a good manager of amount taken from your parents, no, you will try to maintain some balance sheet. Or even for shopping, if you go by taking 1 lakh rupees. So at the end of the day, after coming back from the market, you will account it how much you have gone, where you have gone right, wrong, like that. So some balance like that in cost of money you will do. Similarly, as an engine it is taking, how much useful power it is developing, and how much loss it is leaving. Like that, we are all accounting. It is an accounting of energy taken by the engine in the form of fuel input. Okay. So for that, there is a systematic procedure. And as a objective of this particular experiment is to show that at full load. So how do we arrive at the full load? Thank you. Yeah. So how do we arrive at that one? Because as I told you that last class we saw the engine connected to DC shunted dynamometer. We adapted 2 pi nt by 60 into 1000 into 9.81. But in this particular engine, it is connected to the water brake dynamometer. And here we have some special calculation procedure because it varies from manufacturer to manufacturer and the type of dynamometer connected. So ultimately, we are seeing that 2 pi into some speed, 1500 is the speed of the engine, into WR means it is a torque, no? W into R. R means from the center line of the engine to the crankshaft point, what is the distance at which the load is being acted. That is the torque arm distance, we take it as. So 32 centimeters away from the center line of the engine, the load being acted. So that all we take it, and finally the variable points are the W and the speed. And because it is a constant speed engine, and only W is a variable. So what is the W max? Maximum power we must know. So 3.68 we have seen in the top side, no? So if I equate it to 3.68, we come out around the value of 7.5 units. So if I load the engine by altering the water flow, which is going into the engine, in a short while now I will show the video where exactly water is flowing to the engine, how it is being controlled, so that the engine spring balance will show the reading equivalent to 7.5. Because our experiment is aimed at conducting half the full load, we are trying to load the engine to 3.75 units. Okay. So, but allowing the fuel to engine in such a way that it will run at 1500 RPM, because this is again experiment is at a constant speed. So likewise, we are trying to bring the engine to the half the load or full load at a rated speed, and the remaining observations are made. So let us see the demonstration of the engine while running. Please, Sampath Kumar garu.
Yes, sir. Yes.
So while conducting the experiment, I will also explaining that how it is started, where are the intricate components, and this one. Okay, please.
Sir, is a video available, sir?
Yeah, it is being shown. No,
Yes.
you can play. It's a no volume, no?
It's not coming, sir. Volume is not coming.
Volume is not coming.
Sir, once try sharing files, sir. In share
What?
option, there is file, share file option is there, no, sir. Right side in upper tabs. When you
Oh.
click on share, it will show window, file, whiteboard. Try sharing file.
Why? It's not visible. The video is not visible.
Visible.
Not audible,
Audio,
sir.
sir, audio.
Then
Audio
it's an audio problem, right? Just a moment. So what you are saying? Can you repeat?
Once open WebEx, sir.
WebEx, sir. Should I stop sharing?
No need, sir. Once open WebEx, I want to know something. Like I also don't know, sir, but that option is
No, it is basically played in the morning. When we checked it, actually, it should come. Just a moment. It's basically to do with the voice, nothing
Yeah,
else.
initially it was not there, I think, Dr. Sampath. Afterwards, you gave volume, no?
Can you try now, sir? Let's try once.
Yeah, just you little move it further. No,
No voice, sir.
no voice.
Just a moment. Specifically for this, I just checked in the morning, sir, actually, with another student asking me to join that.
Okay.
Now, sir?
No.
Then probably I may have to.
Yeah, you move it. I will try to explain on my own.
Not required, sir. We played in the morning. It has come. Just give me 2 minutes, sir. Short.
Okay, sure. As Gupta sir said, no, as a video you can play it like.
Sir, I think in YouTube you can play, sir. Sir. This video you can share in YouTube and share that, sir.
Just give me 2 minutes.
Okay, sir.
In the morning, we actually did this.
You are able to hear from your side?
From my side, I am able to listen, sir.
Hello,
Sir,
hello,
while
Sampath sir.
sharing, there is some mic icon, sir. You have to
Yes,
click
sir.
on that.
In the share option, in the top right, automatically optimize. There is an option, sir, and behind it,
Press what? Mute all
don't
option. Mute. This is
don't
what.
share your computer audio. You need to unclick it, sir.
That's what. Switch audio. Check. You are using computer for audio. Should I disconnect it?
No, it's not coming.
It's not happening, sir.
Not coming.
Sir, once unshare and reshare, sir. While resharing, there is some mic button.
Yes. Now you can see my screen, right?
No, sir.
No, normal screen. Switch audio.
Participants' names are being seen.
Thanks. The audio options is there. Audio.
Audio. In
Current.
the menu, it is there, no? Audio, video.
Yes.
So speaker and microphone settings. WebEx Smart Audio settings. No. Okay, Dr. Sampath, I'll try to explain like this only. So please go to the back, no? Start from initial. Yeah. So this, as you are seeing, no, this is the engine setup different from what we had earlier when we are conducting the performance test on a single cylinder engine. Of course, the green part what you are seeing is a engine part. So here this is a dynamometer, and these are all the plastic tubings, no, water flow. As I told you, there's a water break dynamometer. So these pipelines, no, they are going into the dynamometer, and there are control valves by which you can alter, can regulate the flow of water into the dynamometer by observing it. So there are two valves here, and this is spring balance. No? So on which I told you, the 7.5 are so any value. Let us say half the load means 3.75, or part load means again 1.8, or so. Likewise, you can get the values. So this as dynamometer setup is concerned, as I told you, that with the help of the stick I am trying to show you this water flow and in and out of the dynamometer. So now I am trying to show you how the fuel flow is happening here. So when you are starting, this is a decompression lever which is in the vertical position, and there is a camshaft here with the crank lever. We'll try to rotate this for giving initial momentum, and there is a fuel injector here to the fuel injector where from the fuel is coming. So from the fuel injection pump. So this fuel injection to the fuel injection pump, the fuel is coming from the filter, and if you move back, so this one, it alters the amount of fuel being injected for regulation of load or speed. So like a rack and pinion or inventory is controlled to your accelerator pedal in actual engine is connected to that one. So this is a setup wherein we have a exhaust gas calorimeter. So fuel tank is here. So this is a burette arrangement for measuring the flow of fuel to the engine. So second showing the fuel line. So fuel filter, fuel pump, and finally to the injectors. This is a input that is going to the engine. Let us see. This is airflow. So this is intake manifold. Okay, this is intake manifold. Stop చేశారా? Okay, you start moving it when it comes to the water flow, no? So yeah, you see there is a provision for the engine to take water from the mains, main fuel tank, your water tank in the laboratory. It is entering at the bottom side of the engine because it's the engine cylinder head. This is the cylinder. So at this corner, కొద్దిగా రైట్ సైడ్ ఇంకా కొద్దిగా మూవ్ చేయండి. Yeah, so this water flow white line is shown, no? So finally it is going at the bottom side. Here is ఇక్కడ కొద్దిగా ఆపండి, కొద్దిగా బ్యాక్ సైడ్ పోయేసి ఆపండి, ఇంకా కొద్ది. ఇక్కడ నుంచి స్టార్ట్ చేసాము మనం. As the nameplate details are showing that 5 HP and 1500 RPM as usual. So there is a digital indicator. So this is actually meant for knowing the exhaust gas temperature leaving the engine cylinders. So exactly at the exit of engine exhaust manifold. And this particular, the other చూడలేదు. Still I'm showing the dynamometer load reading on the water flow దగ్గర తీసుకెళ్ళండి. ఇంజన్ కూలెంట్ వాటర్. Yeah, exactly. Now you see the water flow is entering at the bottom of the cylinder water jackets, and it gets circulated and gets heated up, and it rises to the top, and finally water leaves from this seal. So we have a thermometer which is inserted here to know the incoming water temperature, and finally it is moving here, and the other side you can see that the water is leaving the engine cylinder. So this inclined thermometer, it is being shown now. See here. This finally, because due to thermosyphonic effect and the convection, the water gets heated up and it rises to the top. Then finally, this thermometer gives you the exit water temperature of leaving the engine cylinder, and finally this water line, white line, it goes out, and where you can collect water, that how much water has been flowing through the engine cylinders. So that is a water line is concerned. Don't get mistaken, these plastic tubings are with respect to dynamometer, and this white tube is with respect to the engine coolant water. Okay, so here we collect the water in a measuring jar. So with the help of this measuring jar, we collect some quantity of water. When you are starting to insert under this one tab, so you start the stopwatch and then collect some water and stop the stop clock. So you can come out and without seeing without having the parallax error. So you note down the time taken, have you measured, no? So you know the quantity being collected and the time you have measured. So you can know the mass flow rate of water. So mass flow rate of water, any heat given out or heat lost is calculated by means of MCP delta T. So mass flow of water, volume flow rate of water we have measured through that jar and as well as time, multiplied with the density will give the mass flow rate, and CP of water, as you know, 4.18 kilojoules per kg Kelvin into delta T. The delta T, as I showed you know, the exit temperature of water and the intake temperature of water. So that is the heat lost through the engine coolant water. And now we have to account for exhaust gases losses. కొద్దిగా బ్యాక్ పంపించింది exhaust gases. So for that we should know what is the temperature of exhaust gases. So for that there is a resistance temperature device what is provided here at the very exit of exhaust manifold. So this is intake air is there. So this is exit, and this finally connected to the, because thermometers they cannot measure very high temperature, no? So there is what is called resistance temperature device with the help of which we measure digitally. This is a thermocouple which is inserted at the exit of the engine exhaust manifold. Okay, so and we have made an arrangement like exhaust gas calorimeter. So normally calorimeter is known for knowing the value of specific heat. So we don't know specific heat of exhaust gases, we don't know mass flow rate of exhaust gases. So what are we trying to do? The exit of the gases of leaving the engine are passing through this tank, and inside we have a circular spiral like tubes through which water is flowing. We have the water which is flowing into this calorimeter, and the gases which are surrounding these tubes now will be absorbed by that heat. So heat which is flowing into the calorimeter and heat absorbed by this water is being balanced. So we don't know mass flow rate of exhaust gases, specific heat of exhaust gases, but this mass flow and specific heat doesn't mean means thermal capacity of exhaust gases. And finally, because we cannot touch it like this, which is provided with insulation, finally the exhaust gases are leaving the engine room laboratory. Okay, so at the very exit we have the thermometer, and finally what is the temperature of the gases leaving the calorimeter with this this digital thermometer. Now you are able to see left side and koodiga. So this will give the exit of the calorimeter, the gases which are leaving. Okay, so we only know the temperature difference between the calorimeter of exhaust gases is equal to mass flow rate of water which is flowing through the calorimeter. So here we have a rotameter. We have provided at the bottom of this calorimeter. Water flowing into the calorimeter and water leaving the calorimeter. You see, this is again another thing. Water flowing into the calorimeter is nothing but water, normal water, room temperature of water, and water leaving the calorimeter is at this temperature. కొద్దిగా వెనక్కి. Yeah. ముందుకుందా? There is a thermometer, no? So here we can know the exit temperature of water flowing out of the calorimeter. So we know the mass flow rate of water because there is a tap I showed, no? Finally it is flowing out. Short while now we will show that how the measuring jar is kept and the collected water. Okay, forward chain. This is flowing out and finally so by inserting your measuring jar, you can collect the water. These are the rotators which are flowing into the calorimeter. When we start the experiment now, you can see the flow of water. So one thing is one pipeline showing the water flowing from the engine cylinders. One outflow is showing the water flowing out of the calorimeter. So we should not get confused. Okay. One is a main important campaign, another is to know the heat capacity of exhaust gases. So likewise, we'll know the thermal capacity of exhaust gas multiplied by temperature difference. We got it equivalent to mass flow of exhaust water, mass heat of water into this temperature difference in the calorimeter of water flow. Okay. So by equating these two, because this is also perfectly insulated, so that the first law of thermodynamics we are equalizing, and finally we are able to get from this the product mass flow of exhaust gases multiplied by heat capacity of exhaust gas, heat of exhaust gas. So finally it is a heat capacity. So how do we calculate? Once we get this product from this calculation, and actually exit temperature of exhaust gases we know, and this exit temperature finally where it is leaving, any engine, any vehicle you run it, it is the ambient temperature to which exhaust gases are flowing. To that expansion is taking place. So from that you will come to know the heat capacity whatever is calculated multiplied by temperature of exit temperature of exhaust gases minus ambient temperature. Okay, that is the outside room temperature. So through which this heat loss through exhaust gases is calculated. That divided by mass flow of fuel into calorific value of fuel. So for every percentage, we are dividing with that. We get finally what do we get? It is a percentage of heat loss through exhaust gases. So now we are ready with the calculations for noting down the different values. So percentage of heat loss through exhaust gases, percentage of heat loss through coolant water, and a useful output. It's an indirect measure of thermal efficiency of an engine. So from 100, if we subtract these values, so we get the unaccounted losses. These unaccounted losses partly may be because of the radiation, partly because of some fuel injection pump which is taking the power from the engine, and there is also a pump which is supplying the lubricating oil to different components. So all those ancillary components we are not exactly noting down. So that makes us to put it into unaccounted losses. So as the load being in this tachometer, it is being shown. So you have provision. Of course, there is another display is being seen. No, display. The second display, that's the display regards to engine speed. This is the second one, right side one you are seeing on the panel. Okay, front part. There is the engine speed. Okay, so I will show you with the arrow. You see, that is the engine speed. Anyway, if you are not happy with this measurement, you can also insert the tachometer either on the crankshaft side or on the camshaft side. The camshaft side, if you insert the tachometer, you may get it around 750 RPM. So your Moni has noted the tachometer reading, you see. 1500 RPM can be seen at the crankshaft side. Okay. Of course, if the display, when the engine is steadily running, so if there are no fluctuations in the load, no fluctuations in the spring balance reading, so your speed also maintained almost constant. It varies slightly by 10 RPM or 20 RPM. Within that range, it is tolerable. So that's how we run the engine. So once you have loaded the engine to the expected at what value, half the full load or 1/4 load, whatever load you have decided to do, so allow the engine to run for some time, half an hour, let us say. So in a half an hour period, the values will come to steady state. And once the values have come to steady state, we are not seeing any fluctuations in the speed. At that time, the temperature of at various strategic points, you note down, and then finally you calculate the percentages and draw the heat balance in the form of pie diagram. Pie diagram is a diagrammatic representation of distribution of losses or energy supply. So I was giving an example that after the completion of presentation of budget, finance minister gives the distribution of fund allocation for various ministries in the form of pie chart. So how do we draw this pie chart? The input what you have given is the mass flow rate of fuel multiplied by kilocalorie of fuel. So many kilowatts it has come, let us say. That kilowatts I take it as a 360 degrees. Okay. So once I get 360 degrees account to that value, so every percentage whatever I have got is how much percentage of this 360 degrees. So with the help of a protracted circle of your own diameter, the diameter is not fixed here. So you can just draw angles corresponding to useful power, the exhaust gases, and the coolant water. Likewise, remaining things you can show with unaccounted losses. So as you are going for higher and higher loads, engine will be developing more power, the unaccounted losses will be smaller. So that is how we conduct and tabulate the readings. Only one set of reading is enough. So at this point, any clarifications you want? Or sir will show how the readings are obtained. Okay, na Sampath garu? Dr. Sampath? Hello.
Sir is unable to unmute, I think, sir.
Sir has not muted. Post. Hello, Sampath garu. Sir is unmute only.
ఆయన వాయిస్ రావడం లేదంట.
Is my voice not audible, sir? Yes, not audible.
ఆయన వాయిస్ నాట్ ఆడిబుల్ అంట.
ఆయన చెప్తున్నారు మాకు జస్ట్ ఏదో విధంగా సింపుల్ ప్రాబ్లమ్స్ వస్తున్నాయి సార్ మనకి. either the problem with the video or
Now is it audible, sir?
you are audible.
Now it's okay.
Okay.
Maybe video audio also
Yeah, some issue is there, sir, because in the morning I purposefully spent some time playing the video with the audio. Actually, one of my TO assisted me. I am not sure why it is not coming now. So this video is being is seen on your screen right now. I hope so.
Yeah, yeah. So while taking the readings, you are showing that video. Hello, Dr. Sampath.
Sir,
While taking the readings also, you have taken video, no?
yeah, this is the video, sir. If you are not seeing any screen, any video now, sir.
Only white
White
screen.
screen. Okay, just I am sharing.
Video is not coming.
One second. Now the screen is shared, sir.
Screen is shared. Yeah. We are trying to start the engine. So you observe that the decompression lever is being engaged. Once the engine attains certain momentum, immediately we disengage it by bringing into horizontal position. There was some problem because we have supplied coolant water, no more.
They can see how it's getting started and the compression lever is operated, sir. As soon as he crank it up, he is switched off the compression lever. Now it got started, sir.
Engine started, no?
Yes, sir.
This 303, 304, that what you are saying, no, exhaust gas temperature leaving the engine. This is speed, 15, 16, 1516. So this is the temperature at which the water flow into the engine coolant, and the water flow out of the engine cylinder is this one, jacket water. We got it around 56 or 58, I believe. So room temperature of water would be around 23 degrees. So this is the water which is flowing out of the jacket waters. there is another pipeline, no? So that is out of the calorimeter. Measuring flask with the help of which we are trying to collect some water, and when you are able, as soon as you are keeping here, you start the stopwatch. You collect some whatever amount of water it may be. Yeah. It's a measuring jar because it is a graduated. You cannot exactly see the level of water in the jar by sitting down. So collect some water, fix it. Some time you fix it. Comes out of that place and see without any parallax there. And I am trying to show you the calorimeter outflow of water. And here we are trying to insert one more jar to know the flow rate of water which is moving out of the calorimeter. So there are two pipelines. No? So here we are inserting. A fuel flow or 10 cc of fuel. There are 10 marks here from this point to there is a point marked here that around accounts for about 10 cc. Once it starts here, reaches here, then you can comfortably at that point you can start the stopwatch until it comes to this point.
Speed and RTD temperatures. With the help of a tachometer, you are trying to find out the RPM from the camshaft. It's taking the same reading at the crankshaft. You can see the fumes coming out through that. The water is so hot that you can see some fumes coming out. See here, some fumes are coming out. See?
Hot vapors.
Yeah, that whatever is coming. So that is about the views. Sir,
Okay.
this is the readings, sir.
So you will be sharing with them, no?
Yes, sir. It's getting
Oh.
shared now. Sir.
Oh, okay. So
All of you note down the readings.
both at no load and full load.
Zoom it, Sampath.
Anyways, I'm sharing the whole folder with them, sir.
Okay, right.
They can also look at the videos as well as this one, the manual, everything, the whole kept in a folder and I shared with them.
Oh, 505 వచ్చిందండి టెంపరేచర్.
These are readings that are taken long back, last semester. Last semester.
Not 5 at a half load,
This is at half load, sir.
So 505 is not a good indication. Engine is not in good condition.
Okay.
So normally, even at full load, no, it would be around 350 to 400. At the full load itself, it is giving this one means it will reflect in the efficiency. When you go to doctor, no, if you take some scan report like that, so after seeing the diagnostics, okay, your blood samples, your urine sample, your ECG readings, whatever you may be. So by looking at that, we can come to know the doctor can ascertain the condition of a patient. Similarly, a good engine test readings can be seen as a condition of an engine. So I'm trying to figure it out whether what is the condition of an engine.
So have you taken the readings, students? Have you finished taking the readings?
Yes, sir.
Okay.
Any doubts at this point of time? One Mr. 193, 101, Sylvester Stallone.
వేరే కండిషన్లో ఇప్పుడు జపాన్లో ఇట్లా ఉంది హ్యాండ్ తోటి తినడు మేనర్లెస్ అనుకున్నాను వచ్చా
Hello? Hello?
Yes, sir.
Government?
There was someone who has
Outside. Stallone. No reply.
Sir,
Who is he?
sir, I'm teaching the student Kaushik, sir.
Yeah, Kaushik.
Sir, water vapors are coming, but the temperature of the outlet water seems to be well below the vaporization temperature. Like
Vaporization temperature means, see, once you come to a simmering stage, there also it starts giving vapors. It doesn't mean that it should give at 100 degree centigrade.
okay, sir.
The phase change, it takes place phase change, and it is not distilled water, So normally the temperature of ordinary water would be coming to the boiling point even before reaching 95.
Okay, sir. Sir, can we apply calorimeter equation at that point? Like it is
Yeah.
somewhat.
It is a calorimeter reading means only mass flow of gases multiplied by its temperature difference is equal to mass flow of water, physics of water into temperature difference flowing out of the calorimeter, you know.
Yes, sir. Some water is evaporating, so some mass will be lost. Like,
And that evaporating is finally flowing out. So it may have some difference with the flow rate of water collection, but that is accounted. See, you collect water, a very small sample, okay?
okay, sir.
Time taken. So you need not have to bother about that vaporization losses.
Okay,
So,
sir.
what is more concerned about this one, I am trying to say is 505 degrees. It
Yes,
is
sir.
clean, and you can cook your food with the exhaust heat.
Yes, sir.
Yeah. So when you come to the subjects like solar energy and other things, you will note the temperature at which these gases have been left.
Sir, why particularly Kirloskar? Is it is there any reason behind it, sir? Why we are using?
Kirloskar make is a standard engines,
Okay, sir.
single-cylinder engines, which are widely used for agricultural pump sets.
Okay, sir.
So single-cylinder engines are more prominent because we can make any modifications what you require. Okay?
Okay, sir.
Yeah, we don't have any contact with the Kirloskar people, so that
Okay,
there are other players also, but they are quite reliable. If you go to market, no, you ask about engine, how much it costs you.
Yes, sir.
So Kirloskar is actually collaborated earlier with Cummins, UK. They are known for the quality of engines. Even
Yes,
there are generators which by name Kirloskar Electric, you know.
Yes, sir.
So there is a company called Kirloskar Oil Engines Limited, Oil, Bangalore. They used to come for placements for our institute earlier.
Okay, sir.
Sir, just checking, sir, whether the audio is coming now.
Sure.
Is the voice coming, sir?
No.
Still not coming, sir. Okay. I'll figure it out, sir, by next week.
అంటే ఒక పని చేద్దామా జస్ట్ ఒకసారి గూగుల్లో ట్రై చేద్దాం అంటారా గూగుల్ మీట్
No, sir. Actually, in the morning, I actually done from Google. Actually, from the web, I tried to join, and I tried, and the voice. The student said that the voice is coming from the recording. But now what I did was like from an app which is installed in my system, I tried to log in.
అంటే గూగుల్ మీట్ లో ఒకసారి షేర్ చేసి చూద్దామంటారా
Google Meet అవసరం లేదు సార్ వాళ్ళకి పంపించేస్తే ఆటోమేటిక్ గా they can look at it actually.
Okay.
Complete things I am sharing with them, sir. The whole folder with all the details.
Yeah.
Okay, sir. It's not playing as you said. It's not.
Yeah. So any other questions? Already people started leaving the class.
Okay.
But it is very heartening to know that out of 170 odd people, only 120, 115 kada maname 5 members ఉన్నాం.
Yes, sir.
So class representatives, please take care of these people now.
But sir, what is the use? Like even if you attend, then there is no we can't see who are attending or who are not. Even if I talk about me, like I try to like understand everything, but still I can't get the things. The virtual things are like worst. I can't get what actually you're trying to convey from that video and also.
Earlier also you faced this problem. Earlier our video was clear, no? Last class.
Yeah, it is okay, but like sir, learning the engines and all from the video is difficult, sir.
Who is that? Jayesh.
Yes, sir.
Jayesh. That's why I told you some people who are nearby us can come and experience. It is not that we have recorded earlier and we are trying to show you. You understand?
Jayesh, do you feel that there's no use of attending the class then?
No, the answer.
Sir, I can't say like this, but yeah.
You are talking as if it is of no use. Why should we
No,
come? Like
sir,
that?
you're trying your best to sir convey everything, sir. You're trying your best, like
Okay, you can see the video later. That doesn't mean that you need not come to the class. If
no,
you
no,
have
sir.
some doubts, we are here to clear those doubts.
Hey, Jayesh, whatever Sir has pointed out, because the very moment of your first query was like that only. It has really.
No, sir, there were two separate things I want to say. Like, if
No,
you try
okay.
to say people like, please attend classes,
No.
there is no use.
Yeah.
He can still go back.
Had
That is
it
the thing about it.
been,
Yeah.
had it been the case where I was not invited any people to come and witness what is happening, you would have not believed me at all. Okay, you
Yes,
were
sir.
showing the video of some years ago. What is that fellow you are trying to show when your video is not being heard? So your people today, they were there. You ask Moni.
Sir, I never told like you are showing previous videos, sir. My intention was not that.
No. If that was the case, did you believe me or not?
Still, sir, if you say like these are this video, then why don't we like believe you, sir? We will believe you.
Because Jayesh, when we speak out, no, the words will come out automatically, whatever is there in your heart. Okay, but that maintains some good relations, and that will make our relations bitter also. See, immediately Gupta sir also felt like it is not that my understanding. Senior professor like Gupta sir also understanding like that means there is something which has come out very bad from your words.
Okay, sorry for that, sir. I didn't mean that.
No, it's
My
not that.
things were like two different things I wanted to say.
Ah.
First thing was you were telling that to CR that tell everyone to attend the classes. But the thing is, even if you compel the students like whatever, like if they don't want to attend, then there will be no use of attending class. I don't mean to say that attending class is not worth. I'm not saying that. Because attendance is not the
See,
sir. We
Jayesh,
can't compel students, sir. Yes, sir.
Jayesh, we are telling the CR just to tell them to attend the class.
Yeah.
It is not his duty also to bring them here. He
Yeah,
cannot
possibly.
compel another person. We know all those constraints. Right? See, if you tell the other people, it is useful if you come to the class, you will understand, you can interact with the teacher, he is answering all the doubts, whatever we are asking, like that, he can give a feedback. So that the other people may show interest and come. It is only that how can somebody bring another person?
Yes, sir. True, sir.
Right? That is not at all possible. We always say you come to the class. Who will listen to us? And even to you also, they will not listen.
It is only with a good
Only
faith.
just to convey that it is useful to attend the class. That's all.
We are conveying to the CRs that try to inform the students who are not available. Okay. So we are not noting down who are absent. Even we are not conversant with your names. Okay. At least Gupta sir was conversant with some names, but Moni was now and then he's coming regularly. I remembered his name. There are some people who contact and give mails. It's not that we want to hurt you, that and it's not a political meeting, no, where CRs are come and push them into the WebEx. Okay.
Yeah, okay, sir. Sorry for whatever I said. Like I never meant
No,
anything wrong, sir.
it is nothing wrong, because whatever it is a truth only. And in my words also, I have said that forcibly you don't bring. Had it been that one, I would not have started my class in the beginning itself, unless all students are attending. Even there is a percentage of 5 or 10%, our duty is to handle the class. Okay.
Yes, sir.
Okay, sir. And like what
From
else we
both
can
sides,
do
yeah,
to understand? Okay, who's it? Anyone else is speaking, sir?
I didn't speak,
Yeah.
because along with you, somebody was speaking.
Yeah, sir. So I wanted to say like what else we can do to understand like more efficiently, sir?
What else you want to understand more?
Actually, just want to say this, that sir, like in online, yeah, it's different than the offline. So, what things we can do more better?
See, Sarthak or Jayesh, you want to understand more clearly means trying to read the books related to this particular testing and performance topics, you know. Okay.
Okay, sir. Okay. Yes, sir.
So you may get some doubts and you can get it clarified.
Sir, is there
Okay,
any
sir.
virtual lab
Thank
on
you.
thermal engineering, sir?
Hello?
Is there any virtual lab, sir, on thermal engineering?
Sorry?
Virtual labs, sir. Last year we have been provided with kinds of machinery virtual labs. Sir.
Virtual labs.
Yes, sir. I mean, it may be.
Thermal engineering, it's not there. It's a term that construction.
See, if I show you videos of wonderful experiments results, which have done very good performance, do you also feel very happy? Definitely. Okay. But what is reality in our laboratory existing is one. Had it been offline classes, whatever you may experience, same thing we are trying to share with you. Okay. Virtual labs means we have plenty of this one. IIT Kharagpur along with the virtual lab, there is an app developed by them. So that we can make you happy, but that is not my kind of way of teaching.
But how does it make any difference? I don't know. Can you just explain who is asking, Jayesh or Sarthak, or who is that? Virtual lab means actually what is that you are expecting from virtual? Animation or something? What is that?
No, it's not like an animation, sir. It's just like a procedure. Just like a
What
procedure.
more you can expect? I am really not understanding. And I
No, sir. I'm not saying to replace this way of teaching, sir. I'm just asking an additional. If there is any possibility of having virtual lab from college. I thought whether it is developed or not, I don't know, sir. If it is having, it will be like we are going to perform an experiment by procedure steps.
One small query from my side, sir. This is Sampath. Students, have you seen the recordings, I mean, video recordings directly shared with you? Have you seen them directly and still you are not able to understand? See, now what is happening is I am showing the video and the professor's voice, unfortunately, I am not able to deliver that voice in the web. So you may be a little bit confused. That I can understand. But whatever the videos that I've shared with you for the last experiments, where the voice is, I mean, where is audio and video is available. So have you gone through it and still you are not able to understand? Jayesh, can you answer me?
Yes, sir. Like we can understand like up to 80 to 90% of the context, but
offline you cannot expect more than this. I am just telling you.
Yes, sir. You are doing your best. I said, sir. Like even if we have attended the labs, which the professor, like I should not say it is recording, but okay, leave that. But yeah, you are doing your best, sir.
No, you tell me what.
See, Jayesh, it's like you are feeling like you are
not able to satisfy getting a feeling of that kind.
See, I mean, even if you come to the lab, whatever we are doing in the lab, that is all being recorded. Whatever possible explanation sir can give, he's spending time and he's giving.
Jayesh,
and
myself, Gupta sir, it is not boasting from our side. Sampath Kumar.
No, sir.
Here in the laboratory for about 1.5 hours in the morning.
In offline, you cannot expect more than this. This is more than what offline you get, right? Definitely.
Exactly. That's also my feeling.
We are spending only on one experiment so much time. There, we explain 4 experiments at the same time, and we spend only just 10 to 15 minutes with each person. Only thing, physically, you are not seeing the equipment. But even experiment also will be operated mostly by technician only. You people will be taking the readings and doing the calculations. More than this, you will not do anything in the offline lab. Don't expect it will be more practical or anything like that.
Okay, sir. Okay, understood.
But you are trying to say something recording like that. It is recording.
No, no, sir. Like, I wanted to say, like, you are doing your best. You are trying your best. You are making it like new videos and all. The professor, like in the previous lab, professor used to just give some values and all, and it was worthless. I was telling that you are doing your best. That was my point, sir.
What is worthless? I am not still.
If you give a top 1 certificate for us, we'll be happy. If you give 0 certificate also, we'll be happy, because nobody can stop us teaching whatever best we can do it.
Yeah,
Okay?
sir. That's true.
So Rome is not built in a day. You understand?
Sir, another thing is, sir, Jayesh, what you are saying is what? It's not worthy, unworthy. What is that word you have used? I didn't
Okay,
understand.
sir. I'll be in trouble now, sir.
No. It's not about trouble. We want to understand you. If we
Sir,
want
sir,
to,
he's not talking about these labs, sir. Like last
Yes,
sem,
sir.
there were some labs we were just provided with values, and it means there were some
okay.
less learning from
I'm
those
just
things.
trying to understand.
That's what we
See.
just wanted to understand.
Point is, professors are so kind enough that they are trying to learn, and I'll not talk anything more, because when they are listening to you, I will definitely listen. The only thing
Yes,
is, I
sir.
was trying to
Mechanical department,
understand.
all professors, sir. I do talk to everyone from other department.
Because
Our department
I'm
professors
telling
are
you
really
from my side, both professors has come there, and if you can see the video, our senior most lecturers, faculty, Gupta sir was holding and showing it to you in the video, and what I could say is they are putting a lot of effort to explain, but unfortunately that video is for 20 minutes. Once you look at the video and audio, listen to the audio properly, then if you don't understand, you can come back and ask in the next lab. There's no problem with that. But first listen to that. I mean, it's very clear. According to me, it's very clear. This lab was taken very clearly. Just take that, because we are trying to improve every lab. So please listen to that. Don't get discouraged very quickly because of the audio is not coming and all. Maybe you may be in little confusion because of that. So just go through that, and if you have any doubts, probably we can answer them. Okay. So don't worry about that. Sir, I'm just requesting them to go through the videos, sir. I'm sharing that whole folder with them.
Okay.
Once if they go through that, I'm pretty sure that they will understand. Because this time I made sure that whenever we are talking about each component, I was trying to focus on that particular part. So if they go through the video and simultaneously listening to the audio, they will definitely they will be satisfied. At least this lab, I'm sure of it. So let's give them one day time, and if you have still any doubts, sometime in the evening or somewhere we can have a doubts session or something, and we can rectify those doubts, clarify those. Okay. What do you say, Jayesh? Is that fine?
Yes, sir. It's fine.
Yeah.
Sir, can you share the folder before day, sir, before the lab?
No, the video is being taken on the same day. I cannot share you one day before. So on the same day we are taking actually. Sir is himself a dean, so he has a lot of work. So it's not really easy. He's somehow managing to come to the lab 9 o'clock and then spend so much of time. Even Gupta sir has come today. So please understand that. So that's why, if it is possible, then the old videos are there. Still they want to take new videos afresh and then show you each part, improvise on that. So a lot of effort is being put on that. So if you want, I can share you the old videos also. But anyways, next time onwards, manual I can try to put forward. If you want, I can share you the manual, and the other things on the same time, on the same day I will share after taking the recording session.
Yes,
Anyways, you please go through that once today, and if you still had anything, you just message me. Then I will talk with the professors, and we will decide whatever they decide. We will try. Okay. Is there any other queries? Please ask.
No, sir.
Prasad sir, sorry if I have put you in between your talk. Sir, are you there, sir? Sir?
Yeah.
So,
Okay, yes, Sarthak, Kalyan and all, right? We understand we have problems and you also have problems, and it is online. It is not a regular class. You understand the limitations, right? And because as a teacher, we want everybody to have advantage and attend the class. And if there is any difficulty, we try to rectify it. But there is no point in getting absent to the class and thinking that it's of no use. For those people only we are telling. And you people cannot anyhow force somebody. Just we want to say.
No, sir, I will
that if you
definitely
are
convey,
happy,
sir.
you
I will definitely convey
convince
to
the other
principal.
people to come. Otherwise, it is their fate. We don't bother about the people who are not at all interested. If there is some interest in the people and if we cannot satisfy them, that is really a thing which we have to think about and we have to rectify. So that's what we are worried about. Right? The people who are not interested, we just don't care about them. Why should we? Am I clear? Even you also need not care about the people who are not interested. Later, don't support them also. And they have to share, right, if there is any difficulty. If they are just getting absent, they will face the consequences in the exam or the result or somewhere, right? Okay, thank you. Thank you all.
Thank you, sir.
So shall we close the session, sir, then?
Yes, I think we can close it.